Hello friends, today we are going to discuss spherical mirrors. What are spherical mirrors? What are the types? And how do they reflect light? Before starting this, the main requirement is that all of you must be aware what a plane mirror is. We all see mirror daily, and what do we have? We have a plane mirror. One side is rough. Usually the back side of the mirror is rough and the front side is polished. So when we stand in front of the mirror, we see our reflection in the mirror. But why does this happen? The reason being, this polished surface of the mirror, of the plane mirror, is very smooth at microscopic level. It's very smooth at microscopic level. So when light falls on this smooth surface, the light bounces back in one particular direction only. So we get a proper image, a proper reflection. And what happens on the rough surface? The back side of the mirror is very rough. It's not smooth at all. So when light falls on this surface, it bounces back in different directions, in all directions, and it gives some sort of disturbed image. And here we get sharp image. So this is how our normal plane mirror works. So now let's start the concept of spherical mirrors. So now, as the name suggests, spherical mirrors are basically curved in shape. They form a part of a sphere. You all must have seen circle and sphere, a ball shaped object. So spherical mirrors, they form a part of a sphere. So they are curved mirrors. Whereas the mirror that we use in daily life, plane mirror, they are straight ones. So when we say that the mirror is a curved one, we can have two types of curved surfaces. One is, and the other is, now what it is, that one of the mirror has this inner part reflective, whereas this outer part is non-reflective. And in another case, we have this outer part reflective, whereas this curved inner part is non-reflective. So first I would like to say that they are non-reflective surfaces. This kind of mirror in which the inner part is reflective, we call it concave mirror, and this kind of mirror in which the outer curved part is reflective, we call it convex mirror. So now by definition, the word concave means having an outline or surface that curves inward, like the interior of a circle or sphere. Having an outline or surface that curves inward, like the interior of a circle or sphere. This is what concave is known as. So that's why the mirror whose inner part is reflective, we call it concave mirror. Whereas the word convex means having an outline or surface that curves outward, like the exterior of a circle or sphere. Having an outline or surface that curves outward like the exterior of a circle or sphere. So the mirror whose outer surface is polished and is reflective, we call it convex mirror. By name now you all must be getting this point, that how these two mirrors are different. Both form a part or a curved part of a sphere basically, because if we complete them, suppose I have this portion, it's a convex mirror because its outer curved part is reflective. So basically they all form a part of a sphere or circle. Here also, like suppose I have this concave mirror whose inner part is reflective. So if I complete this curved part, it actually forms a portion of a sphere or circle. That's why we call them spherical mirror. Though they are not completely spherical, but they form a part. They form a part of a sphere. So these are the curved parts of a sphere. So that's why we call them spherical mirror. And in concave, the inner surface is reflective, inner curved part is reflective, and in convex, the outer curved part is reflective. So now, to understand this better, I have this spoon. This is well polished spoon. It's shining on both sides. So now, as you can see, if I turn it, you can very well imagine that what are the two portions of this spoon can be called. Here, this portion, if you can see, it is curved. It is a curved part. So the innermost curved part is called concave. So this innermost curved surface, that is called concave. So I would say that this is forming a surface just like a concave mirror. And now in case of this outer part, it's a bulging part. So you can see here, if I keep it like this, that this outer surface resembles that of a convex mirror. So since both the sides of the spoon are polished, so I can see an image on both the surfaces. But the only difference that I see here now is when I look into the curved innermost inward curved part of the spoon, it gives an inverted image. So when I look myself into this portion, the concave portion of the spoon, it is giving my inverted image. It is showing inverted image of me. And whereas if I rotate this spoon and if I see myself in the convex part of the spoon, it is giving proper erect image. So this is how you can actually understand both the concave and convex mirror, because the spoon is totally made like this. So if I keep it like this, this inward curve part is concave, and whereas this outer bulging part is convex. Till now we have understood that the reflecting surface of a spherical mirror, it forms a part of the sphere. That's why we call it spherical mirror. So now let's see some other terms associated with these spherical mirror. So here, this is my, which mirror is this? Here I'm showing this side non-reflective. So this is a concave mirror. And here, let me show you the another one. This side is non-reflective. So this is the convex mirror. This sphere, this is the concave mirror, and this here is the convex. So now in both these mirrors, the center, if I pick up here, the center of the reflecting surface of the mirror is called pole of the spherical mirror. So in both these mirror, here this side is the reflecting surface, and here this side is the reflecting surface of the convex mirror. So now I have taken the center of both these reflecting surfaces. So this center of both the spherical mirror is called pole, and we denote it by P. So now the thing to keep in mind is that pole lies on the reflecting surface of the mirror, and pole is the part of the spherical mirror, because some other quantity that we are going to discuss, they will not be lying on the spherical mirror. So now just remember that pole, since I have drawn this on the spherical part of the mirror itself, on the spherical mirror itself, that's why these are the part of the reflecting surface. So the center of reflecting surface of spherical mirror is called pole, denoted by P. Now let fall some rays. Suppose A, B, it's at infinity and light is coming from infinity. So here we can draw like this, that it's light rays from the infinity are falling on the mirror. I'm making the arrows. Similarly, side by side for convex also we can draw the same, AB, and this is at infinity. Light rays are coming from the infinity and falling on the curved surfaces. So one terminology is clear, that is pole. Now the other one. Both these spheres, as I said, that these curved portion, they are basically a part of a complete sphere. So whether we have a circle or a sphere, it definitely has a center. So this portion also has a center. Since it forms a part of a sphere, so they have a center. So this center is denoted by, suppose if this form a complete, like if I show you that if we form a complete sphere out of this, so then the center of the sphere will be somewhere here. Similarly here, if I draw sphere, so the center of spherical mirror, or the reflecting surface of spherical mirror, is called center of curvature, and it is denoted by C. But now, is this lying on the reflecting surface? No. So C is not a part of the mirror, but it lies outside the reflecting surface. On contrary, pole lies on the reflecting surface, but C, it's lying outside the reflecting surface. In case of concave mirror, the center of curvature lies in front of the reflecting surface. And in case of convex mirror, center of curvature lies behind the reflecting surface. Because here this portion is the reflecting surface, so C is lying behind the reflecting surface. And in case of concave mirror, this portion is the reflecting surface, so C is lying in front of the reflecting surface. As we know, if we have a circle, so basically these are forming a part of a circle or sphere, and we have shown the pole and we have shown the center. So now you know that the distance from center to this axis, to this boundary, is known as radius. So similarly here again we have radius. Well, this is the reflecting surface and this is the center of curvature, and here also this is the reflecting surface and this is the center of curvature. So the line joining this pole and center of curvature would be your radius of curvature. So here this portion and here this portion is your radius of curvature, denoted by capital R. So the radius of sphere here also, of which the reflecting surface of mirror forms a part, is called radius of curvature r. And we also say that PC is equal to r. The distance between pole and center of curvature is radius of curvature. Now comes the next term. We have shown these straight lines. Most of these are the light rays, but the straight line which is passing through the center of curvature and hitting the pole, that is called principal axis. So this particular axis here, this particular axis is principal axis, and here this particular axis is the principal axis. The straight line passing through C and P, passing through center of curvature and pole of spherical mirror, is called principal axis, and here also passing through pole and center of curvature, since they all lie on the same line, they are straight points. And moreover, principal axis is normal to mirror at pole. So this is the portion and this is the principal axis. So if we see the smaller part, if we take the smaller part, so we might consider it as a straight one, though it's going to be curved, but a smaller portion is a straight one. So this principal axis is basically normal to the pole in both the cases. It's at 90 degrees, it's making an angle of 90 degrees. Now here a number of rays fall parallel to principal axis. Here we have shown all these light rays parallel to the principal axis. So they are falling on the mirror. After reflection from the mirror, in case of concave, what happens? This portion, this is R. So now after reflection from the mirror, all these light rays, they meet or intersect at a particular point on this principal axis. So usually, suppose after reflection this goes here, after reflection this goes here, after reflection this goes here, and this particular goes here. All these light rays after reflecting from the mirror, from the spherical mirror, they all meet, or you can say intersect, at a particular point on principal axis. Whatever happens on the principal axis. All these major terms, major points of concern, they all also lie on the principal axis. So this particular point of intersection, this is called focus. So this is the focus of concave mirror. And in case of convex mirror, what happens? That they will definitely reflect. Suppose, so in case of convex mirror, what happened? That in reality, these light rays reflect from here. This reflect from this portion, because this is the reflecting part. But these appear to come from a common point, which is again called the focus of convex mirror. And all these center of curvature, focus, radius of curvature, they all lie behind the reflecting surface of convex mirror, whereas center of curvature, focus and radius of curvature, they all lie in front of the reflecting surface of the concave mirror. So we all say that these meeting at a point, we say that all these light rays converge at a particular point. So the point where all the light rays after reflection from the concave mirror converge or meet is called focus of concave mirror, whereas the point from where all the light rays after reflection from the convex mirror appear to diverge is called focus of the convex mirror. So the only difference here is that in case of concave mirror, light rays actually converge at focus, whereas in convex mirror, light rays appear to diverge from focus. So this is a very important portion, very important part which differentiate both these mirror. Here I am denoting this curved portion by Mn. Here also this curved portion by Mn. So now the diameter of reflecting surface of mirror. The diameter of reflecting surface of mirror is called aperture. So here the Mn is aperture. And for spherical mirrors of small apertures means this curved portion will be small. See, if I have these two mirror, so this has small aperture and this has a larger aperture. So for spherical mirror of small aperture, radius of curvature, now you know radius of curvature, which is the distance between center of curvature and pole lying on the principal axis. So this radius of curvature is found to be equal to twice the focal length. So now what is focal length? First of all, the distance between focus and pole is called focal length. PF is called focal length. In both the cases, the distance between pole and focus is called focal length of the spherical mirror. So if the mirror has small aperture, it means this reflecting surface is small, then it is observed that the radius of curvature in that case is 2 times the focal length. We also denote this focal length by this small f. So this is the thing happening for spherical mirror with small apertures. So this confirms that principal focus of spherical mirror lies midway between pole and center of curvature. So in most of the cases, usually the mirror we take, they have small apertures. So by this we conclude that focus lies midway. It is in between, it's halfway the PC. It lies in the center of the line PC. So we can also write that PC is equal to twice PF for spherical mirror with small aperture. So this is all about concave and convex mirror, the introduction. We have discussed how do they look like and what are the various terms and terminologies associated with these two mirrors. And now how the image formation takes place in both the mirror, we will discuss in upcoming videos. Thank you.